Hello everyone, welcome back to Programming in Python learning series. This is session 9. In the previous sessions, we went through the introduction, flow of control, functions, strings, lists, tuples, dictionaries. And in this session, we look at exception handling and the rest of the topics in upcoming videos. In this session, we'll try to understand what exceptions are and how to handle them. First, let's look at errors. What are errors? Errors are nothing but unexpected outputs and are abnormal behaviors while executing a program. They are triggered automatically by the interpreter. And exceptions can be forced also. There are certain types of errors: syntax, runtime, and logical. We will look at them one by one. Syntax errors are incorrect programming resulting in failures, basically, not following the rules of the programming language. For example, if a string has to be within double quotes or single quotes or even triple quotes, but the quotes are incomplete, then the system or the interpreter throws a syntax error. Next is the type runtime errors. These are failures while executing and can be related to the program or system. For example, the program is trying to read a variable that is not defined. There is no syntax error, however, it's not able to find the variable and give a failure. And the next is the logical error. In this case, the program may not fail, but the results are unexpected, incorrect data due to wrong logic being applied by the programmer. So these are purely programming related and have to be dealt appropriately. Here are some samples for syntax and runtime errors. Here I have incomplete string quotes, double quotes, which is showing incomplete input syntax error. And I don't have the parenthesis here. Again, it's showing a syntax error. Here, there's no syntax error. Print hello is still a valid syntax or still a valid statement. However, since there is no double quote, the print statement is expecting a variable which is not defined. So it's throwing a name error. Here, the name error is not a syntax error, it's a runtime error. We'll now look at exceptions. What are exceptions? Exceptions are errors that impact normal execution of program even if there are no syntax errors. For example, we are trying to open a file that does not exist. We are trying to write into a file before creating it, etc. An exception is considered to be raised when an error occurs, and that needs to be handled by the program to avoid any failures. So these things should be handled by the developer. The developer should be able to think through when writing a piece of code or block of code what all possible errors can occur in this particular part of the code, and they should be ready to or they should be able to code to handle those errors. Python comes with quite a few built-in exceptions. They are commonly occurring exceptions defined in the interpreter. So whenever the error occurs, the exception is raised. They deal with common errors provided by providing standard solutions. Relevant exception handler code is executed that gives out the exception name and the reason for the exception. And these exceptions are to be handled by the programmer. We'll look at some of the built-in exceptions provided by Python. Syntax error. Syntax error is also an exception raised when the syntax of the code is incorrect. IO error raised when the file specified in the program statement cannot be opened. Import error. This is raised when the requested module definition is not found. When we try to import a module or importing a module and a function within that, if there is a failure or it's not able to be found, import error exception is raised. End of file error. If this is raised when the end of file condition is reached without reading any data as input. Index error. Name error, type error, these are straightforward ones, and quite a few more. We'll look at some sample programs that throw up built-in exceptions. First one, print 10 plus a string cost. Here we get a type error because we cannot sum up or add a string value and an integer value. So we are getting a type error saying unsupported operand type for plus symbol or plus operand. And the next one is print 25 by FR. Here, there is no double quote or single quote, so this is considered as a variable. But since FR is not defined, we are getting a name error. FR is not being defined. If this FR happens to be holding a string value, then we'll still get a type error after executing that. So depending on where the failure occurs, the type uh, error type is thrown. The next one is syntax. Syntax, we saw that before. This is also a built-in exception. Now we'll see how to raise exceptions forcefully. Python offers two methods, raise and assert, that can be used to raise exceptions with user control statements. Raise, when a raise is used, it interrupts the program flow and the execution of current code block is stopped. Wherever the raise is coded, the execution of that particular block is stopped and the control moves to the part of the code handling exceptions. The code to handle the exceptions are to be managed by the programmers. The syntax for raise statement: raise, give a name to the exception and an optional argument. Next is the assert statement. Assert, how it works is inside the assert block, you have an expression that is being validated or evaluated. If the evaluation becomes false or the assert statement having a negative result or wrong result, an exception is raised. The name of the exception is assertion error. Assert is generally used at the beginning of a function to evaluate an expression and then do some operations, or after a function to validate the data as an output from the function. Syntax for assert is assert, an expression, and an optional argument. Let's see some examples for both raise and assert. Here, this is a sample for raise. Raise exception, an exception is raised here. It's just a simple message coming out of an exception. So when the code is run, there is a traceback happening in the Python shell, and the message that we wanted to project is coming out, and the execution stops there. For assert, here is a sample. So here the assert happens for evaluation of positive numbers. Assert if number is greater than or equal to 0. If not, throw an exception. Otherwise, print the number square, number multiplied by the same number. So when the program is run or the function is run, and I'm passing first 1000 as the number, which is a positive number. So when it is checked, when the assert checks for number to be greater than or equal to 0, it is. So it's going to print number multiplied by number, which is a million. Whereas when the negative check is passed with minus 1, 2, 3, 4, the assert checks for number being greater than or equal to 0, which is not. So it's throwing an exception with a message, oops, a negative number. Handling exceptions. Each exception should be handled within code to avoid program failures. We have to remember an error is caught, but it's not handled yet. I mean, we are forcing or by the system there is an error is caught and exception is raised. How do we handle it? Unless we ask Python to do something about it, either stop there or do something else. Say skip to certain part of the program. Unless it's coded, the program is going to still fail because there is an error happening. So it's basically to avoid the program from crashing. Exceptions can be handled for both inbuilt and user defined exceptions, and useful for catching runtime errors and give appropriate instructions to avoid crashing. Of course, syntax errors, they're going to be coming up by default, but runtime errors like or trying to open a file not being present, uh, instead of letting the program crashing, you can always try to see if a file can be opened, if it is appropriate to do there. So some kind of operations can be done with the exception handling. In Python, exceptions are categorized into distinct types, and handlers can be created for each type. The main code where exception may occur and the code to be executed in case of exceptions are kept separate in exception handlers. The code block where a possibility of error and the programmer can perceive, okay, this is an area where there is a possibility of an error occurring and I want to handle it. So the code block where the error can happen is different from where it is being handled. The interpreter keeps track of positions where the errors are occurring. Now let's look at the process by which exceptions are handled in Python. First, in case of an error, Python interpreter creates an exception object. This object contains details on the error type, the file name, the Python file name, and the position of this particular execution block in the program, etc. These are important in case of handling. Once that is handled, if there's a need to come back to the mainstream program, it's very useful. The exception object that is created in case of an error is handed over to the runtime system, which tries to find out if there is any code block available to handle exception, which is called exception handler. These two steps, the creation of exception object and handing over of this exception object to runtime system, these two steps together are called throwing an exception. And once the exception object is handed over to the runtime system, it searches for a handler, as I said earlier. It searches for a handler that's a code block within the method where they occurred. Basically, it tries to look for the error being handled within the code block or the function itself. If it is not able to find the handler within, it is going to search for the entire program sequence in the reverse order. The list of methods is referred to as a call stack. When there is a method encountering error, if there is a method calling that method, it's going to search for a handler in the calling method and so on in the reverse order. If there is a handler found, the code within the handler block is executed. This is called catching the exception. If the handler is not found, there is no handler defined anywhere in the entire program for a particular error or an exception, the program is ended. Here is the process in a flow diagram format. First, an error occurs in a particular method and the interpreter creates an exception object and hand over to the runtime system for finding out if there is a handler coded somewhere. These two together are called throwing exception. And the runtime system looks for a handler in the current method first. If there is a handler within the method that encoded the error, if it is found, execute the code, which is called catching the exception. If not found, search for method within the call stack, that is called forwarding exception, meaning I'm not able to find a handler within the method and that encountered the error. So I'm trying to trace back in the reverse order. Still, if there is no handler found, terminate the program. But if there is a handler found, execute the code, which is called catching the exception. This is the basic flow of how an exception handling process happens. Now let's look at catching the exception. We saw earlier that executing the code within the handler is called catching the exception. Let's see how it is done. An exception is said to be caught when the code inside the exception handler is executed. Exceptions are caught in the try block and handled in the except block. There is a try and except combination which is provided by Python where try something, try to do something, except in case of something happening, do this. Each try block is followed by an except block. When an error is encountered, the control is moved from the try block to the except block. This is syntax. Try. Do some activity program statements where exceptions might occur. Say if I'm trying to perceive or as a programmer, I see a possibility of an error occur in a particular place. I code those statements within a try block, except in this particular case. I'm giving an exception name and code to run in the case of an exception happening. There are some samples here. I'm writing the code block or a set of statements where I perceive there might be a possibility of an error. So I'm writing those statements or giving those statements within a try block. Numerator equal to 100. Denominator, I'm going to receive from the device, input device, or the user is supposed to enter. Remember, we have the input receiving format. integer of input. Any input given by the user in this input form will be a string value. So I'm converting that into integer to do a numerical operation. Quotient is numerator by denominator. Print the quotient. And print division performed successfully. But if there is an error, there is a possibility of an error occurring. That's the reason I'm giving it to a try block. Except in case of zero division error, say for example, denominator is expected from the user, right? The user enters 0. In case the user enters 0, deal with it, say print denominator as 0, not allowed. Because zero division error is a standard exception. Any number divided by 0, it's going to throw an exception by default. But when that error occurs, what am I supposed to do? What is that I'm expected to do? Or is there a way I can handle it myself? That's the whole purpose of exception handling with try and except block. So in case of zero division error, print denominator is 0, not allowed, and print outside try except block. So if it's a proper division, it's going to say division performed successfully. Except in the case of zero division error, it's going to say denominator is 0, not allowed. This is how the result is appearing when this particular code block is executed. Say I'm entering a denominator of 20. The quotient is 5. Division performed successfully. Whereas I enter the denominator as 0. So it's going to throw, the except block takes over because in the try except handling block, once there is an error occurring, the control moves to the except block. So here we are coming to the except block, denominator is 0, not allowed, and it's outside the try except block. What if there is a possibility of more than one error in the same process? Here there is an example where there are more than one exceptions. The one we saw earlier, the zero division error, and if I'm expected to give a denominator, it's not just an actual number, a proper number or 0 that I can enter. I can enter a special character accidentally or intentionally. I can enter a alphabet. So how do we handle that? So that's something we can do by adding more and more exception cases. Try all this or try these statements except handling 1, except handling 2, or just say I've not come across any of this, but there is still an error, still handle it with the message. So in this case, I'm having a value error exception. Say it's not a number, it could be a special character, an alphabet, it's a value error. So say only integers allowed, or have another handler saying except print unknown exception. I do not know what exception it is, but there is an error, say unknown exception. So these are the results when this block is executed. If there is a 0, the previous example similar to this, denominator is 0. But if I entered an alphabet, it says only integers allowed, and I'm coming out of the except block. Try except else sample. There's a possibility of having an else condition to give a proper conclusion. Say in this example case, we have a try block except zero division error, except value error. If there is no except, when it has not encountered any of this errors or exceptions handling, print the quotient as actual value. And this is how we are getting division performed successfully. The quotient is for a successful execution. If not, the appropriate message or error handling happening here. Try except else finally. The statements under finally are always run. This is to kind of conclude appropriately. Say I have a try block, few except blocks, else, and finally. Regardless of what happens in try or except or else, the finally is always run. Say I have a try block, a proper execution, and a failure. Still, I have the finally statement getting executed here. There's another sample here. Say I'm kind of closing or commenting the value error. I'm just having zero division and see what happens here. See, I have the value error kind of blocked out. So if there is a value error, say I entered uh, an alphabet or a special character, it's supposed to throw, which is throwing out. And the statement within the finally block is also getting printed. The end of program, either a successful run or an error scenario in handling. The comment or activity under finally block is getting executed. Let's have a quick recap of exceptions and exception handling. Error occurs when the rules of programming language are not followed. Syntax errors are showstoppers. Nothing moves forward from there. An exception is a Python object representing an error that holds the details of the error, like file name, position of the error, and so on. Python throws an exception when an error is encountered. Raise and assert statements are used to raise exceptions forcefully. Exceptions need to be handled within the program whenever they are raised. And exception handlers are code blocks designed to execute when specific exceptions are thrown. This is called the exception handling process. The control jumps to handlers whenever exceptions are raised. An exception is said to be caught when the code inside the handler is executed. An exception is caught in the try block and handled in the except block. Try except else and try except else and there are finally are few other options. The code under finally block is always executed. If there are unhandled exceptions, the finally block is executed before the Python exception message is displayed. Some commonly occurring inbuilt exceptions: syntax error, value error, IO error, import, end of file, zero division, index, name error, type error, and workflow error. Let's look at some exercises that you can try out. Write a program that prompts the user to input two numbers and raises a type error exception if the inputs are not numerical. We have some samples we looked at. We can just build up from there. Write a program that prompts the user to input an integer and raises a value error exception if the input is not a valid integer. Write a Python program that executes an operation on a list and handles an index error exception if the index is out of range. And write a Python program to execute a division and handles an arithmetic error if there is an arithmetic error. And of course, as usual, you can look at a few other samples or few other exercises yourself and try to code for them. See you in the next session. Thank you.